1 by 3 mn c square. And from from this equation, we derived total kinetic energy, and that is 3 by 2 RT, and average kinetic energy, and that is 3 by 2 KT, where K is Boltzmann constant. In total kinetic energy, R is gas constant. And after that, we studied different types of molecular velocities: RMS velocity, average velocity, average velocity is average of velocities of gas molecules is called average velocity, or arithmetic mean of velocities of all gas molecules is called average velocity. RMS velocity is square root of mean of squares of velocities of gas molecules is called RMS velocity. Students, did I give equation for RMS velocity in last class? No. Okay. Equation PV equal to 1 by 3 mn c square. Let us consider Avogadro number of molecules present in that molecules. Then PV equal to 1 by 3 small m into Na c square. We know that Avogadro number of molecules into mass of one molecule, and that is 1 mole of gas, molecular mass of gas, mc square. Then c square equal to 3 PV by m. From this, c equal to square root of 3 PV by m. Student, this is the formula for RMS velocity. Square root of 3 PV by m, where P is pressure of the gas, V is volume of the gas, and m is mass of the gas, molecular mass of the gas. Okay. Generally, density equal to mass per volume. Then V by m is 1 by d. 1 by d equal to V by m. So this equation we can write as 3p by d. Another equation. Na molecules, it is 1 mole. For 1 mole, ideal gas equation PV equal to nRT. So for n equal to 1, PV equal to RT. In place of PV, we can place RT. So this is another equation. 3 RT by M. RMS velocity formulas: root over 3 PV by M equal to root over 3 RT by M equal to root over 3 P by D, where M is molecular weight, D is density of the gas, temperature must be in Kelvin. Completed. Remaining students. In average velocity, equation mu average velocity, u average velocity, square root of 8 PV by pi m, or square root of 8 p by pi d, square root of 8 RT by pi m for 1 mole. Students, for average velocity, these are the formulas, but no need of derivation part. Just remember formulas, no need of derivation part. And this is average velocity formula. And relation between average velocity and RMS velocity. RMS velocity equal to 1.085 average velocity into average velocity. If you know RMS velocity, you can find average velocity. Or if you know average velocity, you can find RMS velocity. RMS velocity equal to 1.085 into average velocity. Yes, completed. And the third kind of speed is, velocity is most probable velocity. Most probable velocity. In a container, 100 gas molecules are present. 100 gas molecules, obviously, They don't have similar velocities because they move randomly in container. They can collide with the other molecule or walls of the container. So frequently the velocity of gas molecules changes. In 100 gas molecules, let us consider x speed, y speed, z speed, a speed, b speed, so many speeds. But in 100 molecules, most of the molecules, let's say 45 molecules, are having this y speed. Remaining all molecules, they have different kind of speeds. 55 molecules, they have different type of molecules. In 55, 10 molecules are having x, 5 molecules are having a, or less than 45, maybe 35 molecules are having z. But most of the fraction, let's say 45 or 55, having y velocity. This y velocity is called most probable velocity. Example, in class 100 students are present. In chemistry, some students are getting 94, 95. Some students are getting 30, 35. But most of the students, let's say 65 students, they got 75 marks. This 75 marks is the most probable marks. I mean, most fraction of molecules containing speed is the most probable velocity. Okay, so students, the velocity possessed by most fraction of the most fraction of gas molecules is called most probable velocity. Students, do you understand my point? What is most probable velocity? Very easy. The velocity, that maximum number of molecules containing, that is most probable velocity. And most probable velocity mu mp, so not mu, it is ump equal to square root of 2 pv by m, square root of 2 p by d, square root of 3 rt by m, 2 rt by m. So this is the equation for most probable velocity. Mu u RMS velocity equal to 1.224 u most probable velocity. So this is the relation between RMS velocity and most probable velocity. Yes, completed. Next, what is the relation between RMS velocity, most probable velocity, and average velocity? U RMS, U average, U most probable velocity. Equation for RMS velocity is square root of 3 RT by M. Average velocity square root of 8 RT by 5M. And the most probable velocity square root of 2 RT by M. Students, for same gas, let us consider same gas at constant temperature. M will cancel, temperature will cancel, R will cancel in each and every formula. Then remaining are square root of 3, square root of 8 by 5, square root of 2 by square root of 2. And if you solve this, you will get 1.224 is to 1.128 is to 1. This is the ratio of RMS velocity, average velocity, and the most probable velocity. One interesting point, students. This question is given in this year advance to 2020 J Advance. In J Advance, they have given this question. What is the ratio of RMS, average, and most probable velocity? Direct question in advance. One 1.224 is to 1.128 is to 1. Yes. Omkar Aditya, I said leave some space in average velocity. I have given one formula. Square root of 8 RT by 5M. You have to write this equation in that place. So from this, we'll get idea for a same gas for 3 different velocities, which one is always higher? Always RMS velocity is greater because 1.224. Next, average velocity is greater. Next, most probable velocity is greater. For any gas, at constant temperature, always RMS velocity, next to average velocity, next to most probable velocity. Yes, students completed. And the next one is derivation of gas laws from kinetic gas equation. Derivation of gas laws from kinetic gas equation. Kinetic gas equation is, yes, from we can derive Boyle's law from kinetic gas equation. According to kinetic gas equation, PV equal to 1 by 3 mn c square. Let us consider for 1 mole of gas, then PV equal to 1 by 3 mc square. Here n equal to Na. We can write this equation PV equal to 2 by 3 into 1 by 2 mc square. 1 by 2 mc square is what? 2 by 3 kinetic energy. And we derived one formula. Kinetic energy is directly proportional to absolute temperature. Total kinetic energy or average kinetic energy, whatever it may be, kinetic energy directly proportional to temperature. Kinetic energy equal to, let's say, K dash T, where K dash is the proportionality constant. Some proportionality constant, K dash. Substitute Ke value in this equation, then PV equal to 2 by 3 K dash T. Let us keep temperature constant. When temperature is constant, 2 by 3 value constant, K dash is already constant, even temperature also constant, then equation is what? PV equal to constant. When PV equal to constant, it says pressure is inversely proportional to volume at constant temperature. So this is the derivation of Boyle's law from the kinetic gas equation. Students in examination, particularly public exam, they're asking this question: derive gas laws from kinetic gas equation for 4 marks. Either they ask postulates of kinetic theory of gases or derivation of gas laws from kinetic gas equation. So you have to derive Boyle's law in this way. Students, you have to remember form what definitions of all these and postulates, because for public exam you have to write at least 8 marks question. You have to write at least one paper or 1.5 paper answer. For 4 marks you have to write at least one page. So even after class, please try to remember all the things like postulates or definitions, because you need to write an examination. In case if you get hydrogen spectrum for 8 marks, you need to write all the things elaborate, even diagrams. So while preparing for IIT and JEE mains exams, you have to prepare public exams also. Do you have textbooks, Nana? Did you get textbooks, NCR textbooks? So you have to get NCRT textbooks. NCRT textbooks, if you read properly, 40% of questions only from textbook. In JEE mains or JEE advanced, if you follow strictly NCRT, you will get 40% of questions only from textbook. Line to line, if you prepare, if you understand line to line, no need of other reference book. Only NCRT. Particularly for chemistry, more than 40% you will get questions in JEE main from only NCRT. Because you won't get all the things at a time if you don't have any book. You have to maintain proper notebook and you have to note and each and every concept. After solving practice proton sheets, if you get a different question, you have to note that question in class notes. Yes, students completed this. And similarly, you can use same thing for the Charles law. Charles law, PV equal to 2 by 3 K dash T. You can write same derivation part. You will get PV equal to 2 by 3 K dash T. Here, pressure is constant in case. Then equation is V by T equal to 2 by 3 K dash by P. 2 by 3 is value constant, K dash is already constant, P is constant, then V by T is constant. So V by T is constant means volume is directly proportional to absolute temperature at constant pressure. It is Charles law. Yes, completed. Even you can derive Gay-Lussac law. Gay-Lussac's law. Volume is constant, Gay-Lussac law. Same equation, then P by T equal to 2 by 3 K dash by V. Everything is constant here, so P by T is constant. When P by T is constant at constant volume, P is directly proportional to T. It is Gay-Lussac law. Okay. Next, derivation of Graham law of diffusion. We know that Graham law of diffusion says rate of diffusion or effusion is inversely proportional to square root of its density or inversely proportional to square root of its molecular mass. This is the Graham law of diffusion. From kinetic gas equation, RMS velocity equal to square root of 3 RT by M. Velocity of gas molecules increases, their rate of diffusion also increases because gas molecule move with high velocity, they can easily intermix with other gas molecules. So we can say from this, rate of diffusion is directly proportional to velocity, whether it is RMS velocity, any kind of velocity. So here R is directly proportional to at constant temperature and constant pressure. So T value constant, R value constant, 3 value constant. So R directly proportional to C. From this we can say R is directly proportional to 1 by root over M, because C is 1 by C is, we can say C is inversely proportional to square root of M at constant temperature and pressure. So similarly, rate of diffusion also inversely proportional to square root of M. Students, do you understand? Okay. So I repeat here. Generally, Graham law of diffusion is rate of diffusion is inversely proportional to square root of its mass, molecular weight at constant temperature and pressure. And we know that RMS velocity formula square root of 3 RT by M at constant temperature, then RMS velocity RMS velocity is inversely proportional to square root of M. And general observation, rate of diffusion is directly proportional to velocity. Velocity of gas molecules increases, rate of diffusion also increases. If R is directly proportional to RMS velocity, then R is inversely proportional to square root of M. Got it? Okay. Students completed. So please read all the things, students. RMS velocity, average velocity, and kinetic gas equation, total kinetic energy, average kinetic energy. Question is, which of the following gas has highest RMS velocity at 25 degrees Celsius? Option A, O2. Option B, CO2. Option C, SO2. Option D, CO. Vikrant, very good. Neha, very good. Anshu, very good. Shruti, very good. So question is, which of the following has highest RMS velocity? We know that RMS velocity formula square root of 3 RT by M, where M is molecular weight. So molecular weight is very high, RMS velocity. Molecular weight is very low, RMS velocity very high. Oxygen 32 and it is 64. Carbon 12, oxygen 16, 28. Which is having lowest molecular weight? CO. So it has highest RMS velocity. Students understood? Very easy question. Next question is, Calculate pressure exerted by 10 to the power of 23 gas molecules